Hello class, this is Rekha Venkateshwarlu, Assistant Professor of Physics, Government Degree College for Women, Nalgonda. In the last class, I discussed about the introduction of radioactivity, where I covered the what is the radioactivity and radioactive radiations, and what is the reason for radioactivity, right? So in the today's class, the plan of my talk is the representation of alpha, beta, gamma decay. Then we'll discuss about properties of alpha, beta, gamma. Next, loss of radioactivity, and then we talk about activity and the units of activity. Okay, so what is the radioactivity? This is the phenomenon of the spontaneous emission of alpha rays, beta rays, and gamma radiation by an radioactive substance. So this is because only for the stability of the nucleus, this was generally exhibited by the heavy elements which are having the mass number greater than 210 and atomic number greater than 82. Okay, now these radioactive elements are emitting the three kinds of radiations. One is alpha radiation, second beta radiation, the third one gamma radiation. First, let us see the alpha decay, right? So, radioactive decay is of three types. One is alpha decay, the second one beta decay or beta disintegration, the third one is gamma decay or gamma disintegration. So, the representation of alpha decay, let us see the first one. So, here let us consider a nuclide ZXA. It gives rise to an alpha particle plus Z minus 2 Y A minus 4. Generally, any nuclide is denoted as ZXA. That is the atomic number. A stands for mass number. X is the symbol of the element. So here this is the radioactive element. This is called parent atom or parent nuclide. It is emitted alpha particle. Then the daughter nuclide formed is denoted by Y. Here what is we are observing? The atomic number Z decreases by 2 units. The mass number A decreases by 4 units. So we can write it as like this also. ZXA gives rise to alpha particle is denoted as 2He4 plus Z minus 2 Ya minus 4. So in alpha decay, the charge is conserved, the nuclear number is also conserved. Here Z, atomic number, Z minus 2 plus 2 Z, balanced. Here mass number is 4, there is a total number of nucleons, both protons and neutrons. Here 4 plus A minus 4 equal. So in alpha decay, the conditions required are number 1, the charge to be conserved, the second, the mass number must be conserved, right? So you know that I think you observed alpha particle is denoted as 2He4 because alpha particle is the helium nucleus He plus 2, right? Now coming to the beta decay, how to represent the beta decay? As I mentioned in the earlier class, it is two types. One is the beta minus decay, second one beta plus decay. Okay. So the first you see beta minus decay. Here the equation can be represented as ZXA gives rise to electron plus Z plus 1 Ya plus antineutrino nu bar. Here also the charge is conserved and mass number is also conserved or the nuclear number is conserved. Left side of the equation, the Z number of protons, here minus 1 plus Z plus 1 will get Z, mass number A, here A. So in beta minus decay process, when the radioactive element is emitted, the electron, along with that neutrino is also emitted out. Here atomic number increases by 1 unit, but there will be no change in the mass number because electron mass is very negligible. Therefore nucleus mass change is negligible. This is called beta minus decay. The second type of beta decay is beta plus decay. Here, instead of electron, positron will be emitted out. This reaction can be represented as ZXA gives rise to positron. It is denoted as plus 1A0 plus Z minus 1 YA plus neutrino. Here nu is the neutrino. This is the positron. Plus 1 E0 is positron, right? This is parent nuclide. This is the daughter nuclide. Okay. When the radioactive element emitted the positron or beta plus particle, atomic number is decreases by 1 unit, but there is no change in the mass number, right? So this is the beta plus decay. Okay. Now the third kind of decay is called gamma decay. Okay. It is represented as ZXA gives rise to, this is ZXA, we write it as some star. Same ZXA plus gamma radiation. So this happens when the radioactive element nucleus gets the excited state, then in coming to the normal state that emits the gamma radiation. Generally gamma decay takes place by following the either alpha decay or beta decay process. That means when the radioactive element emitted the either alpha particle or beta particle, then the nucleus will get the excited state. So then after some nanoseconds, again it gets the ground state or normal state. So due to the energy difference, the electromagnetic radiation gamma will be emitted out. Therefore, since gamma ray photon has no mass and no charge, there will be no change in atomic number and also mass number. So you can see from that equation. Right. The next topic we are going to discuss is the loss of radioactive decay. The first one is, already I told you that here when alpha particle is emitted out, atomic number decreases by 2 units, mass number decreases by 4 units. This is the first one. Therefore, the position of the element in the periodic table displaces left side to the 2 units. The second, if the radioactive element emitted the beta particle, generally beta minus, then atomic number increases by 1 unit. There will be no change in the mass number. The radioactive element emits the gamma radiation. There will be no change in atomic number and as well as no change in the mass number. So the fourth point is the rate of disintegration of radioactive element. We denote it as dN by dt. It is directly proportional to the number of radioactive atoms n at that instant. We write it as dN by dt is equal constant minus lambda n. This is called the law of radioactive decay. Here lambda is the proportionality constant. Lambda is called as decay constant. Decay constant. So in the formula we have the minus sign, where minus sign indicates that the number of nuclei of the radioactive substance decreasing with increase of time. Okay, so from this we can define the lambda. Lambda equals to dN by dt by n, right? So it is the ratio of the rate of decay to the number of atoms present at that instant is called lambda. Lambda units second inverse, right? Lambda value depends on nature of the radioactive substance. Therefore, different materials or different radioactive substance will have the different lambda values. Now, if you draw the graph between, if you draw the graph between the number of atoms versus time by taking the time on x-axis, the number of radioactive nuclei or atoms on y-axis, the graph will be like this. Okay, this is at t equal to infinity. So this point represents n0. That means at t is equal to 0, at the beginning of disintegration, the number of atoms n0. As the time passes, the number of radioactive nuclei or atoms are decreasing exponentially. So this is represented by this one. So now you consider the equation dn by dt is equal to minus lambda n. Okay. From this, you write n terms one side, dn by n is equal minus lambda dt. Integrating both sides, okay. What I am saying, integral of dn by n is equal minus integral lambda dt. Integral of dn by n gives log n is equal minus lambda is constant, writing outside of the integral. Integral of dt is t plus integration constant, say c. Here at t is equal to 0, say the number of nuclei n is equal to n0. Then substituting that, we get log of n0 is equal minus lambda t plus lambda t0 plus c. Then c is equal log of n0. Substituting this value in this equation, then what we get, log of n is equal minus lambda t plus log of n0. Okay, now bring this term left side, log of n minus log of n0 equal minus lambda t. We can write this as ln of n by n0, here base e, equal minus lambda t. Okay, removing the logarithm function, you can write n by n0 is equal e power minus lambda t, or n is equal n0 e power minus lambda t. So this is the exponential law of radioactive decay. So from this, it is we can understand very clearly the graph taking between time versus n. Okay, then you will get graph like this. So the graph indicates what, the number of radioactive nuclei atoms decreasing exponentially with increasing of time. It doesn't cut the x-axis. At t is equal to infinity, up to t equal to infinity, it's gradually goes on. The number of atoms decaying is decreasing. So here this is the point corresponding to t equal to 0, the number of atoms n0. Right. This is the law of decay or the law of disintegration of radioactive substance. The next concept is activity. What is meant by activity? So the law of radioactive decay exponential law, what we derived, n equal to n0 e power minus lambda t. You take that one, n is equal n0 e power minus lambda t. Differentiating both sides with respect to t, what we get, dn by dt equal n0, the differentiation of e power minus lambda t, e power minus lambda t into d by dt of minus lambda t, you get minus lambda equal to minus lambda n0 e power minus lambda t. If you take the magnitude, dn by dt equal to lambda n0 e power minus lambda t. This is the activity of the radioactive substance, R equal to dn by dt. Nothing but what? The rate of disintegration or the rate of decay, R is equal to Lambda n0 we can write r0 e power minus lambda t. So from this equation we can write n by n0 is equal e power minus lambda t. From this equation we can write r by r0 equal e power minus lambda t. So then n by n0 equal r by r0 equal e power minus lambda t you can write. This is the activity. Activity is defined as dn by dt, the rate of disintegration or the rate of decay of the radioactive substance, the number of atoms decayed in 1 second. The units of activity are the units of activity is Curie, Curie, Rutherford, Becquerel, and so on. 1 Curie is equal 3.7 into 10 power 10 disintegrations per second. Then what is 1 millicurie? Will get 3.7 into 10 power 7 disintegration per second. If you want to express in microcurie equal 3.7 into 10 power 10 power 4 10 power 4 disintegrations per second, or 1 becquerel is equal to 1 disintegration per second. 1 Rutherford is equal to 10 power 6 disintegrations per second. These are the different units for activity. So in our today's class, what we discussed, the first, what is alpha decay, its representation of beta decay, representation of gamma decay. Then we talked about the loss of radioactive substances. Loss of radioactive substances when alpha particle is emitted out from the radioactive substance, then atomic number decreases by 2 units, mass number decreases by 4 units. If the beta particle is emitted out, atomic number increases by 1 unit and mass number doesn't change in the case of beta minus. But whereas in the case of gamma radiation, there will be no change in atomic number as well as mass number. Right. So out of these three radiations, alpha, beta, and gamma radiation, if we compare the properties of these three, we can discuss that. The first, charge. So what is alpha particle? It is a helium nucleus, He plus 2. So it has 2 units positive charge. Okay. Beta particle is nothing but what? It is an electron, fast electron coming out from the nucleus. Therefore, it has the 1 unit negative charge, minus 1. Its charge equal to electron charge. That is what? 1.6 into 10 power minus 19 coulomb. What is the charge of gamma? Because of it is the electromagnetic radiation, no charge. Therefore, its charge is 0. Alpha particle is 2 units positive charge. Beta particle has 1 unit negative charge. Gamma has no charge. 2 units positive charge. Hence, we can write it as 2 into 1.6 into 10 power minus 19 coulombs in terms of this is plus. Beta particle charge, this one, it is 0. The second point, mass. Alpha particle, already I told you, helium plus 2. Helium contains 2 protons and 2 neutrons, right? Therefore, here mass number 4. Hence, its mass is equal to 4 AMU. Because beta particle is electron, its mass equal to electron mass. That is 9.1 into 10 power minus 31 kg. Okay. Gamma is the photon, electromagnetic radiation. Photon rest mass 0. Therefore, the rest mass of the photon is 0 here. Okay. The third point, the speed. The speed of alpha particle ranges from 1.4 into 10 power 7 meter per second to 2.05 into 10 power 7 meter per second, right? Beta particle speed It is point of this is 33% to 90% of the speed of light. It moves with the speed of light c, that is called 3 into 10 power 8 meter per second in the vacuum or free space. Next, ionization power. Ionization power, alpha particle has the more ionizing power. Comparing to the alpha particle, its ionizing power is 100 times less than. And comparing to the beta particles, gamma rays has the less ionizing power, 1 by 100 the ionizing power that of beta particles. Because alpha particle has the more charge, therefore its ionizing power also more. Next, penetrating power. Penetrating power is inversely proportional to ionizing power. Therefore, alpha particle has less penetrating power. Beta particle has 100 times greater than that of alpha particle. Gamma particle penetrating power is more than that of the beta particles. So out of these three, gamma radiation has the high penetrating power. Right. Photographic plate, affecting the photographic plate. So here alpha particles affect the photographic plate, beta particles affect the photographic plate, gamma radiation also affect the photographic plate. Now, when the incident on flow barium sulfide, zinc sulfide or barium platinocyanide, then alpha particle produce fluorescence, beta particles produce fluorescence, gamma also produce fluorescence, right? So here alpha particle range in air 3 centimeter to 6 centimeter. It is in the order of meters, and its range is very more comparing to the alpha and beta. So these are the main properties of alpha, beta, gamma. What, let me repeat. Alpha particle are positively charged particle, beta particle negatively charged particle, gamma has no charge. Alpha particle mass 4 times to the proton mass or 4 AMU. Beta particle mass equal to electron mass, gamma has no mass. The speed is more for gamma radiation, less for alpha particle. Ionizing power is more for alpha rays and very less for gamma radiation. Penetrating power is more for gamma radiation and very less for alpha particle. Both all three kinds of radiation affect the photographic plates. Three kinds of radiation produce the fluorescence when they incident on a material like zinc sulfide, barium platinocyanide. So this is the properties of alpha, beta, gamma radiation. Thank you.